And I'm going to figure out the LCM for 3, 4, and 8. It's 24 work, right? All three of those can multiply evenly into 24 or be divided by 24, meaning that 24 is a common multiple, right? 3 times, 8, 4 times 6, 8 times 3. They all can be multiplied by some amount, doesn't have to be the same amount, into 24. 24 is divisible by each of them, to think about that. And 24 is the least common multiple, right? There are other common multiples, 48, 72, 96, and so forth. So that's the LCM. And so basically it can be divided by each of those is another way to think of it. With this middle section of terms, x, 2x to the fourth, and x to the third, we're going to create something that can be divided by each of those. So for something to be divisible by 2, we would need to have a 2 in it. For something to be divisible by x, we would need an x in it. And in fact, how many x's do we need for all those terms to be divisible? 4 of them, right? Because there's an x to the fourth. So that's the biggest exponent there. And essentially, I could divide all of those by a 2x to the fourth, and that would divide evenly. There wouldn't be a remainder. So you look at each component, the coefficients and the variables, and say, hey, what do those all multiply into? All right. Over on the right, you might think those are 3 completely separate factors that have nothing in common, and so your LCM has to contain all 3 of those factors on the right. But if you factor them out, you'll see that there actually are some commonalities. Can I factor anything out of a 5x plus 20? A 5 can, right? Aren't those both divisible by 5? So I could write this as 5 parentheses x plus 4. And then how about this middle factor, x squared minus 16? Can I break that apart into 2 smaller binomials? Hopefully you recognize one of those special cases, right? What would those 2 factors be? Take the square root of each, 1 plus, 1 minus. So that's an x plus 4 and an x minus 4. Then the last thing we have is just a 5. So now look at these 3 different groupings. Let me separate it a little bit clearer there. And the LCM is going to be just a new combination of factors that basically contains each of those separate groupings. So first look at the coefficients. What coefficient do we need in our LCM? A 5, right? There's a 5 in 2 of those, so I'm definitely going to need a single 5. What else do we need? Look at some of those other factors. Yeah, we're going to definitely need an x plus 4 because a couple of them have x plus 4s. And what else? What's the third piece that we would need? Yeah, an x minus 4. So in terms of polynomials, identifying the LCM or least common multiple, this is what we're going for. Do we have all of the factors? So 5, x plus 4, x minus 4 would be the LCM. I could divide that by each of those previous terms, and it would divide evenly. They're all multiples of those original factors. So a way to kind of think of this is when we were adding and subtracting these rational expressions on our last lesson. Remember how we had to get all the denominators to be the same? And we'd kind of ask, hey, what's missing? Like, what's that other denominator have that this one doesn't? And you're trying to make a combination of all of them that match. So that's going to be the same skill that we're using in today's lesson. Dun, 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 dun. 8.2, solving rational equations. 4 steps. Please jot these down in your notebook so that you can refer to them. Nice and easy. Step 1, just like multiplying and dividing and adding and subtracting, is you want to factor everything. Break every single polynomial apart into as many smaller components or smaller factors as you can. So you can see those individual parts, just like that third warm-up problem, how we factored it first, then we could see that there was some stuff in common already. Once it's all been factored, we essentially want to look at those denominators, and we want to make them the same. Think about the LCM. This is just like adding and subtracting. We needed to have a common denominator. So for solving these equations, we also want to have a common denominator. So like make sure every denominator has the same pieces. Once they're all the same, all the denominators are the same, then we can essentially cancel them out. What we're really doing is we're multiplying both sides of the equation by that LCM. So it's just going to cancel out each of those denominators. And that's great because then we no longer will have any fractions in our problem. And it's just going to be a regular equation then. We can just solve it. But the big thing here, and I mean, I've been stressing this a lot this unit, is to factor, factor, factor. That should always be your first step for every one of these problems. Factor everything you can. Break it down as much as you can. Factor, factor, factor. All right, so here I've got a rational equation because there's an equal sign, so we need to solve this for r. And our goal is to try to determine, well, what number could I plug in for r that would make this equation true? So it's 24 over r minus 3 equals 36 over r plus 3. Now we could guess, right, and just plug in random numbers, but we want to do this mathematically. So look at the two denominators. And remember from last lesson, I always stress, make sure you group up any of those numerators or denominators with parentheses to remind you that that's a single entity. It's a single factor, a single grouping. And I can't separate the r from the minus 3 or the r from the plus 3. So even though they both have an r in the denominator, that's not like a common piece that I can't just add 3 to one or subtract 3 from the other. Those are two completely separate factors. R minus 3 is one number. R plus 3 would be a completely different number. And so I essentially want all the denominators to be the same. I want them to have all the same components. So one thing that you might want to do, and I kind of have this off to the side, the LCM, is to identify this first. You don't have to do it this way, but you can. And it helps kind of clear things up where if I want all these denominators to be the same, well, just look at each of the factors in every denominator and make sure you've got every one of those factors accounted for. So one factor I see is an r minus 3. So I know that that is going to be in my denominator. I want that to be part of this common denominator. And the other factor that I see is an r plus 3. So that would be my least common multiple. So I want those are all the different denominators that I have in every single part of this equation, right? Are there any other denominators that I didn't account for yet? Any other factors, or is it just those two? Just those two. So I want every denominator, both of them in this case, there's only two fractions. I want both of them to have each of those components, an r minus 3 and an r plus 3. All right, so looking at the left here, on the left side, there is an r minus 3. So what factor do I still need to give this fraction on the left? What's it missing? An r plus 3, right? And so I'm going to just simply multiply by an r plus 3. And since we're multiplying these fractions together, whatever we multiply the denominator by, we must multiply the numerator by that same amount of r plus 3. Because that's equal to 1, we're allowed to multiply by 1. And now if I look at the fraction on the left, it's got two factors in the denominator, right? An r minus 3 and an r plus 3. right? Because like that's what it was missing from that other fraction. So we go to the other side, and we play the same game. We say, all right, what's missing from the denominator? It's got an r plus 3. What does it need in the denominator? Thank you. Yeah, an r minus 3. So it's got both of those factors in the denominator now. But we need to multiply the numerator by that also. And let me just clean this up a little bit. 24 times r plus 3 over r plus 3, r minus 3 equals 36 times r minus 3 over r plus 3 and r minus 3. So this is our fraction that we have now. Do the denominators match? What do you think, everybody? Let's play the matching game. Are they the same? Yeah, of course they are. All right, so if that's the case, I guess the shortcut thing is going to be you can just ignore them. You can cancel them out. Now, mathematically, how can we do this? Well, in an equation, aren't I allowed to multiply both sides of the equation by the exact same amount to keep it balanced? Like if I multiply the left side by 2, can I multiply the right side by 2 and it's still an equal balanced equation? So instead of multiplying by just like a 2 or something like that, what if I multiply the right side by an r plus 3, r minus 3? Then I have to multiply the other side by that same amount by r plus 3, r minus 3. And if I multiply by that on the right and the left side, it's still balanced, right? I multiplied by the same thing on the left and on the right, which we're allowed to do. But then look at this fraction overall. See how I've got an r plus 3 on top and an r plus 3 on the bottom? I also have an r minus 3 on top and an r minus 3 on the bottom, leaving this left side as simply 24 times r plus 3. Over there on the fraction on the right, I've got an r plus 3 on top, r plus 3 on bottom. Those would cancel out. R minus 3 on top, r minus 3 on bottom. Those would cancel out. And I'm left with a 36 times r minus 3. And now look at our equation. Are there any more fractions? Nope. Do you think you could solve that equation as it's written right now pretty easily, everybody? Like, what do you have to do to the number in front of the parentheses? Just distribute it, right? Combine like terms. Go ahead and solve that right now for me. Figure out what is r going to equal from this line right here with the red and purple. Go ahead, distribute, combine like terms, and solve that equation for r. Let me know what you get. It's fine if you want to get a calculator. Anyone got 15 for r? So once you get rid of those denominators, it's a piece of cake. This is an algebra 1 problem. This is like a pre-algebra problem, right? It's pretty simple, very straightforward. So the one skill is getting rid of those denominators. Yes, sir. You can if there's just one fraction on each side. Do you think I'm going to leave them that easy for the rest of the lesson? No. Definitely not. But that is a very good point to make. So Gavin pointed out, just from the original problem here, when you've got just one fraction equal to one fraction, this only works if there's just one fraction on the left and one fraction on the right. You can cross multiply, saying 24 times r plus 3 equals 36 times r minus 3, which you'll realize that, that was the exact calculation that we did. 24 times r plus 3 equals 36 times r minus 3. Right? Isn't that what I had you work on? Like once we got to that point, that was the exact calculation. We just got through to that point by getting those denominators to match. All right. But if there is just one fraction on the left and one on the right, sure, cross multiplication does definitely work, just like when you dealt with similarity back in geometry so many years ago. Oh, good times, good times. So that's the second way you can answer it, but that's only if it's one fraction on each side. All right, I want you to write this problem down again. I'm going to show you another way to solve it. I know there's 3 different ways. Gavin jumped the gun with the cross multiplication. That's good. Remember how I had you identify the LCM to start? That wasn't entirely necessary. That problem, we just kind of looked at each denominator and we wanted to make them the same, and it worked for us. If you do identify the LCM, though, r plus 3, r minus 3 in this case, what you can do, and this works if there's 2 fractions or 3 or 4 fractions, however many rational terms there are, you can simply multiply each numerator by the LCM. And when I say multiply, I don't mean actually perform any calculations. Just like write it next to it, right? If I were multiplying 24 times that, I would just write this r plus 3, r minus 3. It's like I'm multiplying that in the numerator with the 24. Don't actually distribute or anything. Just write those factors out by each numerator. Same thing here, r plus 3, r minus 3. Which I'm allowed to do, right? Because if I multiply the left side by some value, I multiply the right side by that same value, we're allowed to do that. It keeps the equation balanced. So I multiplied both sides of the equation by this LCM. And now looking at the fraction, check it out. What do I have on the top and bottom that can cancel? Well, there's an r minus 3 on top and an r minus 3 on the bottom. For the other fraction, I have an r plus 3 on top and an r minus 3 on the bottom. Now you didn't even have to deal with denominators at all. They canceled out. And as long as you multiply by the true LCM, every denominator will cancel. And what are we left with? Well, I've got 24 times r plus 3 equals 36 times r minus 3. And look, there it is again, that same basic equation that we just solved for r. So I've had students over the years prefer each of these methods, and it's a pretty even split. So that's why I wanted to show you these 2 different techniques for solving these. Find the one that works for you, that makes sense in your head, and stick with it. So if you're better with trying to get all the denominators to be the same, like when we added and subtracted, use that technique. Otherwise, multiplying everything by the LCM is another valid technique to get rid of fractions. Cool? Maybe? Kind of? We'll keep practicing. Let me show you another, a more simplified illustration of that, of getting rid of a fraction. This is something you can do with any type of equation when you have a fraction in it. So let's say you've got something like 2/3 x plus 5 equals 8. What if you had just a basic fraction like this? Basic equation with one fraction in there. How many terms are in my equation, first off? Can you identify how many terms there are in the whole thing? Just use your fingers if you want. 3 of them. Yes, good, good. 3 different terms. And if any of them have a denominator, have a fraction in it, a really cool thing you can do is simply multiply everything, each term, by that denominator. I can multiply every single term by that denominator, which we're allowed to do because it keeps the equation balanced, right? The left side and the right side are being multiplied by 3. But when you do this, look what happens. When I distribute that 3 to each of those terms, well, 3 times 2 over 3, for that first term, wouldn't those 3's cancel out and leave us with just a 2x? Then when I distribute to the other terms, you're going to get plus 15 equals 24. And look at the equation now, everybody. Wouldn't you rather solve the equation in blue than the equation in green? Since it doesn't have a fraction anymore, it's kind of nice. So that's kind of like what we're doing by multiplying by this LCM, the least common multiple of the denominators. In this case, there was only one denominator of a 3, so we multiplied by 3. Well, what if our equation were a little bit different? What if it were 2/3 x plus 5/2 equals 8? Well, this is kind of cool also. I have multiple fractions, and we hate dealing with fractions, don't we? We never want to deal with those. They're just unnecessarily tricky. But if I multiply this entire equation by the LCM of the denominators, they'll all go away. So how many denominators do I have here? 2 of them, yeah. A 3 and a 2. What's the least common multiple of 3 and 2? A 6, right? So think of a number that they both go into. That is the LCM. I could multiply by 3 and then multiply by 2, but if I just multiply by 6, which is the LCM, something really cool happens when I distribute it to each of these. First, 6 times 2/3. What's 6 times 2? 12. Good. What's 12 divided by 3? So that first term becomes 4x. No more fraction. How about that next term? What's 6 times 5? It's 30. What's 30 divided by 2? It's 15. 6 times 8? 48. Check it out. No more fractions. They all went away. It's a super convenient, I guess, trick to not have to deal with fractions anymore. And you can do this for any equation, not just these rational functions that we're dealing with in this unit, but that's something that you can always use on any type of equation. If you multiply by the LCM of the denominators, then those denominators will essentially cancel out. They'll go away, and you'll be left with just a nice non-fraction equation that all of you can solve blindfolded. Maybe. You wouldn't know where to write, though. It would be messy. But you could do it. Pretty sure. So that's the idea behind multiplying these rational functions by the LCM. You want each denominator to cancel out with part of that numerator. All right, go ahead and try this one on your own. X over x minus 3 plus 1/3 equals 1. Now we can't just cross multiply in this case because you've got 3 fractions. It's not just one on the left, one on the right. Our goal is to simply get rid of all of those denominators. And recall that x minus 3 is separate from 3. Those are two different factors. They're not the same. You can't combine them or anything like that. So we want to get rid of all those denominators or make them all the same so that they all cancel out. It's up to you how you want to solve it. Let's see what you can do. Take a minute. Try something. Don't be scared to mess up. Write something down. Make a mistake. That's fine. You'll learn from it, but you have to actually give it a shot right now, okay? Yeah, you can definitely make that one a fraction also. It won't make too much of a difference with its denominator for like an LCM because it's just a 1. But you do need to think of that. That's another fraction. It needs to have that same denominator if you're trying to get them all to match. So think about the LCM. You can either multiply everything by the LCM of the denominators, or you can try to get all the denominators to have those factors in them. But just try something. All right, looks like you're giving it a good effort. I love that. You got to try. You can't be scared of messing up. Did anyone identify the LCM? A 3. And what else? And an x minus 3. All right, do I need the 1 of that other denominator? No, I mean, you can put a 1 in there. It's not going to change anything. Divided by 1 doesn't affect our value. All right, so I either want to make all the denominators the same as this, a 3 parentheses x minus 3, or I simply just multiply every numerator by this. Personally, I think that it's sometimes more difficult to identify the LCM, but if you do, it's a lot easier to use than making all these fractions, right? Like in this case, it's pretty easy to see what the LCM is going to be. It's each of those two pieces, the x minus 3 and the 3. So in this case, I can just multiply each numerator by a 3 parentheses x minus 3. This gets multiplied by 3 parentheses x minus 3. And this gets multiplied by 3 parentheses x minus 3. You multiply every numerator of every fraction on both sides by the same amount, which we're allowed to do in an equation because it's balanced. What I do to the left side, I did to the right side. And by just writing it there, remember, I didn't even multiply anything yet. I didn't do any calculations. I simply wrote the LCM in each of the numerators. And now look at them as complete fractions with all those terms in the numerator and denominator. And looking at this first fraction, what can cancel out? What's on the top and on the bottom now? This x minus 3 and that x minus 3. Okay, go to the second fraction, that 1/3. What can I cancel out in that second fraction now? What's on the top and on the bottom? 3 on the top, 3 on the bottom. Gone. Over on the right side, the last thing, well, there isn't anything that cancels out. You can cancel out the ones, I guess. 1 divided by 1 is 1. Won't make a difference, really. But if you want to, you can. And if you look at this, every denominator has canceled out, meaning we no longer have a rational equation, essentially. I only have values in the numerators, so just write them out. This first term is x times 3. Well, we would write that as simply 3x plus. This second numerator has a 1 times x minus 3. Well, 1 times x minus 3, if you want to write that, you can. And finally, on the right side, we have just a 3 times x minus 3. And look at that equation in blue. It's a very straightforward linear equation. Just distribute, combine like terms, and solve. Go ahead, everyone, solve this from here if you haven't yet. No, that totally works. So you multiplied everything by a 3 to cancel out one of those denominators. Then you multiplied everything by an x minus 3 to cancel out the other denominator. Works 100%. Yeah, that's totally fine taking it in steps. Very good. Oh my gosh. What'd you get? All right. Yeah, go ahead and distribute. Combine like terms. Solve.
Oh, I have to distribute them.
Yes, sir. So distribute that 3 to both of those. Right, whatever's in front of the parentheses, you distribute. Yeah.
You got one.
Yep, don't forget to distribute on the right. So you need to distribute the 3 to both of those. Yeah, good job, Joy.
I just wanted to show you, I did this, but I never distributed to this, but I ended up getting the same thing. I ended up getting this one. That was one of them.
So this isn't correct, though, any of those, because you do need to multiply the right side by that as well.
Yeah, so
Like you got these denominators the same, those denominators the same. So these would also need to have those same 2 factors in the
I
denominator.
started from your equation.
Oh, yeah. Did you distribute the 3? Good job. Yeah, nice. What'd you get? Hey, good job. Yes, good work. Yeah. What'd you get? Oh no.
Where do I go from here?
So now just like combine like terms. Get all the x's together on one side, get all the constants on the other side. And close. Let's see. When you add 3 to the negative 9,
Oh,
what's that going to give you?
always the negative numbers that
So, no, they're tricky. They're very tricky. All right, so on the left side, I have 3x plus x minus 3, right? If I distribute a positive 1, it just gets rid of the parentheses. For some reason, everybody, for some strange reason, a lot of students did not distribute this 3. I don't know why. but like half the students I looked at, they just wrote like a negative x plus 3 or something weird like that. Just basic distribution, right? 3 times x is 3x. 3 times negative 3 is negative 9. Right? And then when you combine like terms on the left side, 3x plus x is 4x. I can add 3 to the right side to give us negative 6. Subtract 3x and x equals negative 6. Who got negative 6? I saw a bunch of you. Very good. Gosh, I hope it's not extraneous. Do you have to worry about extraneous solutions with these, do you think?
Yeah.
It's a very easy check. You do have to, but it's a very easy check. Because what's the one number that you can't divide by, everybody? 0. You can't divide by 0. So just look at your denominators and make sure if you plugged in a negative 6 for x, would you get a 0 in any of the denominators? No, you wouldn't. So not extraneous. But if we had something like x equals 3, like if this were the solution, we'd say, no, that's extraneous because over here we'd have a 3 minus 3, which would be a 0, and we obviously can't divide by 0. So you could get extraneous solutions. Just be aware of it. I know that's evil, but it's an easy check. Just don't divide by 0. It makes the world blow up, apparently. Even your calculator can't do it. Go ahead, try to divide by 0 right now on your calculator. Whoa! It's like your brain is a calculator. All right, example 3. Go ahead and write this one down. Y plus 2 over 2y plus 1 equals y over 3 plus 3 over 4y plus 2. There's a lot of different factors in the denominator to get the LCM. Can I break any of those denominators down? Can I break any of those apart? Yeah, look at that third one. 4y plus 2. What do you notice? What can we do? Yeah, take out a 2. Now, why would we want to do that? Well, if I take a 2 out front, the GCF, this becomes 2y plus 1. Why is that a nicer way to write it? Yeah, now do we see how we have a common factor? We have a 2y plus 1 there and a 2y plus 1 over here. So those are actually part of the same factor, which is great. So look at each of those denominators. And I need to build or create the LCM based on each factor from every denominator, making sure that every denominator's factors are accounted for. So obviously, we see that there is a 2y plus 1 in those denominators. What else do you see in some of those denominators? There's a 3. So we've got to put a 3 in there. Anything else? The 2. Do we need the 2? Even though we technically have a 2 right there, don't we? Do I need a separate 2, though? Is that a different factor? It is, right? Because that 2, remember, it's part of a bigger grouping. It's part of a polynomial. You can't, like, single it out. And so we do need to account for this additional 2. And is that it? Do I have now the factors from each denominator accounted for in our LCM? Yep. And we can rewrite this. 3 times 2 we know is 6. So I'd write the LCM as 6 parentheses 2y plus 1. So that's what I'm going to use for my least common multiple. Now let's multiply every numerator by that LCM. So recall that the way we do this is you don't actually multiply it out. You simply are going to write it in each numerator spot. So I've got a 6 parentheses 2y plus 1. Here I've got 6 parentheses 2y plus 1. And this last term, 6 parentheses 2y plus 1. I'm multiplying every numerator by that LCM. Now look at each fraction separately, and all of the denominators should cancel out. Now if I look at this first fraction, I see that there's a 2y plus 1 up top and a 2y plus 1 in the bottom. That denominator canceled out. Look at the second fraction. I see a 6 on top and a 3 on bottom. What's 6 divided by 3, everybody? It's a 2. So the way I'm going to write this is I'm going to cross out the 6 over 3 and just rewrite it as a 2, because 6 divided by 3 is 2. And then this last term, this last fraction, there's the 2y plus 1 that cancels. And then for the coefficients, I have a 6 divided by 2. So the 6 and the 2 divide out to become a 3. So I'm changing that 6 over 2 into a 3. At this point, you should have every denominator crossed off. Once you do, then we go ahead and we rewrite this new equation with just the numerators, the parts that we didn't cancel out. So that first fraction, we've got 6 parentheses y plus 2. Then we have an equal sign. And this middle fraction, my coefficients are a 2y parentheses 2y plus 1. And then the last fraction, all I have is a 3 times 3. So plus 3 times 3. So I didn't do any calculations in that step. I just rewrote it to get a clearer picture of the problem. So see if you can follow those steps to get to that line in purple. Once we have the line in purple, the equation without any denominators, just distribute combined like terms and then solve for y. Six y plus 12. Be careful with this middle one. 2y times 2y is 4y squared. plus 2y. And then 3 times 3 is just 9. So after we distribute, we see that we've got y squared and we have a y. So this is going to be a quadratic, so we're going to get 2 answers. Perhaps. Whenever you have a y and a y squared, or an x and an x squared, we want to then set it equal to 0. Move everything to one side. Get a 0 on the other side. So I've got my 4y squared. I have a 2y. I'm going to subtract 6y to get negative 4y. And then 9 minus 12 is negative 3. And then we factor. Uh-oh, a isn't equal to 1. That means we have to use 5-step factoring. You want to go through that again? Yes, Mr. Wojcik. Yes. It's a skill you should be able to do, no problem. 4 times negative 3 is negative 12. Are there two numbers that multiply to negative 12 and add to negative 4? Where are they? Correct. Negative 6, positive 2. So I'm going to rewrite this middle term as a negative 6y plus 2y. Keep the 4y squared in front and the minus 3 at the end. We just rewrote that middle term as two separate smaller terms. We have 4 terms. We use factor by grouping. Group the first 2 terms together and the last 2 terms together and divide the GCF out of each of those separately. Four y squared and negative 6y. What's the GCF of those 2 terms? Yeah, 2y. That leaves us with a 2y minus 3. That second factor, though, 2y and negative 3, does it have a GCF? 2y and 3. There's no common factor. So what do? This one's a little different because we do need to have some type of a GCF. What's the one number you can always divide everything by? You could divide a 1 out of them. And so if that ever happens, if there is no GCF when you do this, just take out a positive 1 and leave it exactly the same. It's still a 2y minus 3. Because look at the 2 parentheses. Do they match? Yep. So one factor is going to be the 2y minus 3. What's my second factor going to be? You look at the 2 GCFs. 2y plus 1. From here, you just set each of those equal to 0 and solve for y. So that first factor, y is going to be 3 over 2. For the second factor, it's negative 1 over 2. So those are the 2 values that would make each of those a 0. That was a nice surprise. I didn't think we were going to get to do some 5-step factoring today. It's like the skills that you were taught earlier in the year, we still are supposed to know. So like we're not supposed to learn something just for a test and then forget it the next day. Like this is supposed to be a long, enduring type of process to learn everything. Are either of those extraneous? Oh. 3 halves and negative 1 half. Just look at the denominator. Ooh, negative 1 half. If you plugged a negative 1 half here, 2 times negative 1 half is a negative 1, and negative 1 plus 1 does equal 0. So that would give you a 0 here. So negative 1 half is extraneous. So we only have one solution. 3 halves. Isn't this a great way to start the morning? Get your brain going. Like after math class first thing in the morning, are you ready for like anything? Because like every other class is going to be a piece of cake, or is it you used up all your brain power first hour that the rest of the class is a waste? Which one is it? Does it help or does it drain? Or does it just depend on the day? Yes, you can. You call him slim. He doesn't need exercise. Any questions on these? I know this one was longer because it had that extra step, but I just want to make sure that I still refresh your mind on earlier skills. Wow. Hey, this one looks fun, doesn't it, everybody? Don't worry, this is probably the last one. Oh, no, it's not. Wait, how many more? Okay, 2 more. Yes. I mean, if we don't practice now, when are you going to practice? Be honest. Just not do it at all? Just not learn anything? Sure, welcome to high school. As a 9th grader, here's your diploma. Not going to learn anything anyways, right? No, of course you are. You are learning. You're pushing your brain. You're stressing it out. That makes it grow. Do you know how muscles grow? Like how your muscles get stronger? Do you know what actually happens? Did anyone actually know the actual physiology? Yeah, like when you're lifting weights to get stronger, to get bigger muscles, you're actually ripping your muscles apart and then they're regrowing back on top of it. And when they regrow an additional time, they're adding the additional layers. They're getting stronger that way. Kind of like whenever you get a scrape on your hand or something, it scabs over, like you put more layers of like skin that grow on there. The cells go to there to make it stronger. Same thing happens with muscles. You work them out so they rip apart and they rebuild stronger than before. Guess what? Math is ripping your brain apart and you're just rebuilding it stronger every time. It's the same thing. So you're going to have like big brains from now on. So the more difficult a problem, just think of it as like you're lifting heavier and heavier weights and your brain's just going to get stronger and stronger. You got the answer already? How about this? What's the first step? Yes! Awesome! Factor the denominator. What is the factored denominator? That sounds perfect. Excellent job. Well, no, I factored it myself in my head and I got the same thing. So I trusted myself. Okay, so first thing is you factor that denominator and rewrite it that way. We don't even ever need to go back to that original form with the x squared minus 7x plus 10. Now look at each of these denominators. Are they almost the same? Yeah, they're pretty close, aren't they? So let's build the LCM. What's one factor that we know we need? Yeah, they all have an x minus 2. What else do we need? There's one with an x minus 5. So if even one fraction has that, we have to include it as part of the LCM. Now are they all accounted for? All the factors in every denominator? And that LCM. All right, now what I want you to do is multiply each numerator by that LCM. Cancel out those terms or factors that are on the top and bottom. And then solve it for x. All right, so I'm having you do a little bit more on your own this time compared to the last problem.
I don't think it comes out nice unless I did something wrong.
You could be a fraction. Looks good. Your final answer can be a fraction. You forgot the plus 1 of that middle fraction. That one right there. It's still there. It's still plus 1. So even though the denominators would cancel out, you'd still have a 1. You're going to have a fraction at the end. Yep, that's right.
Is it extreme?
You tell me.
No.
Write it in each numerator, correct, and then see what cancels out. And every one of those 3 fractions, the denominator will cancel out with something in the numerator. Remember, this is a fraction still. It's still under a 1. It's 1 over that.
So can you for like an extreme solution, do you have to plug it into all of them, or can you just plug it into one?
You would have to check each denominator, but really, if you look at these denominators, there's really only 2 variations, either an x minus 2 or an x minus 5. And without even plugging this in, just think to yourself, hey, what value for x would give me a 0 if I subtracted 2 from it? A 2. Is it a 2? Definitely not. How about this? What minus 5 would equal 0? Positive 5. It's not a positive 5. No other options, so I know that it's not extraneous. You can just kind of look at it that way. Instead of having to plug in the fraction and do the math, you can be pretty sure, no, it's not going to give me a 0. Yeah, that's right. Good. You got something?
0.
You got 0, huh? I think you forgot to put the plus 1. And you forgot that there's a 6 in front that would have to be distributed. And so when this cancels out with that denominator, you'd still have a 1 there, right? Because anything divided by itself equals 1. There's still a plus 1 for that middle fraction. We get something? Nope, this is right. Keep going. What I would do, since you've got the 26 here on the left, subtract the x over there instead. Like get the constants on one side, always get the x's on the opposite side of the equal sign. How many x's are you subtracting? Just one of them? If you had 6 x's, you subtract one of them? There you go. That's your answer. You get something?
Yeah, I got x equals 5 2.
Perfect. Exactly right. I saw a lot of students. What? It's like magic. Okay, so you multiply every numerator by this LCM and go through and what cancels out. The first one, the x minus 2's cancel. The middle one, you got to be careful. X minus 2's cancel and x minus 5's cancel. And I saw a number of students then just not write anything at all. Now, if that were true, that would indicate that this simplifies to 0. But technically, what number do you get when you divide anything by itself? You get 1, and there is still a 1 here. So we need to write that plus 1 for this middle fraction. That's essential still for this solution. You need to make sure that you still have that 1 there. This last one, those minus 2's cancel out. And so when we rewrite this, we're going to have x minus 5 plus 1. That plus 1 is coming from this middle fraction equals 6 parentheses x minus 5. And that's the equation that we're going to be solving. So on the left, you have x minus 4 equals 6x minus 30. And I can add 30 to the other side to get 26. I'll subtract x from both sides to get 5x. Divide by 5, and x is 26 over 5. Just leave your answer like a fraction. If it doesn't divide, totally fine. Anyone else get 26 over 5? That's really good. Look at you, you're doing a little bit more on your own each time. And you're getting there. All right, so for this last one, I'm going to have you do the whole thing all by yourself. That's right, I'm not even going to factor for you. But I will remind you, the first step, factor. Here we go. Oh, man. Those are some evil factors. I told you about those ones, right? The 7 minus x. If you flip the order of those two, what else do you have to do? A negative one. It's like 7 minus x. We want that to be x minus 7 instead. You're allowed to do that only if you change the sign of it, multiply by a negative. It's like you divide it out a negative. And hey, that denominator on the right, x squared minus 49. I wonder if that could be factored. And look at those other two factors on the left, an x plus 7 and an x minus 7. Difference of squares, something? Alright, so you factored everything. What's the LCM? The least common multiple of all the denominators. That's right. So go ahead and multiply each numerator by those, or just write those two in each numerator and see what cancels out in every fraction. All right. Remember, it's got to multiply to the constant and add to the linear. You just flip-flop that. I think that should be an 8. Is there... Add the -7 plus 2. You get something? Still working? Uh-oh. Well, it's a quadratic. Get everything to one side. Like you'll have 3 terms like a x squared plus something x plus something equals 0. No? Yeah?
Yeah.
Okay, so I see x squareds and x's. What's that mean to you? It's a quadratic equation, so get everything on one side. Yep, and then try to factor it out. So remember the last thing you do is just what does x equal to make those a 0? So you'd say, so basically like if x minus 7 is a 0, what would x have to equal? Yeah, that's just the last step. That's awesome. Great job. This middle term should be an 8x. Yeah, the last step, x equals what and what? Remember, you just flip the signs? Boom. Well, so remember, this put equals 0 still.
Yeah.
Now check it out. If
I just did that.
oh, and it has to add to a -8. So what should those two signs
They
be?
were minus. I just
Okay, keep minuses. Don't.
X equals.
So if x minus 7 equals 0, what would x have to be to make that true?
Plus 7.
A positive 7, right? So one answer is for x equals 7. That's what we mean when we say flip the signs, right? You just, once you have factors, the solutions are just the opposite numbers. Yeah, what'd you get? Yes. 7 and 1? Did he just teach you something? He really, because you had the wrong answer, he had the right one, and he told you what to do, and you went, oh yeah, like you realized he was correct. Did anyone else hear that? Like that, he just corrected, like Slim for the win. All right, so x plus 7, x minus 7. LCM is an x plus 7, x minus 7. So you simply put this LCM in each numerator. X plus 7, x minus 7. X plus 7, x minus 7, x plus 7, x minus 7. So you identify that LCM. Then just have a cancel party. Just cancel anything out that you can. Those are gone. Those are gone. And both of those are completely disappeared. What I'm left with in the first fraction is an x, parentheses, x minus 7. This is now a plus sign because I had to take out a negative to switch the order of those two terms. And that's 1 times x plus 7, which will still just be x plus 7, equals simply 2x because those other factors canceled out. Distribute, and we get x squared minus 7x plus x plus 7 equals 2x. We're solving for the variable, but there's an x squared and an x, meaning this is a quadratic equation. So you want to bring everything to one side, right? Set it equal to 0. That gives me x squared. Negative 7x plus x is negative 6x, but I also have to subtract this 2x, which gives us a negative 8x. And then there's just a plus 7 equals 0. To solve this, we factor it. What two numbers multiply to positive 7 and add to negative 8? X minus 7, x minus 1. What's our solution? This is where you flip the signs, right? Each of those factors has to equal to 0. That happened if x were a positive 7 or a positive 1. And are either of those extraneous?
Oh, yes, they are. Sorry.
How can we tell if they're extraneous or not? Look back at those denominators. If you plugged a 1 or a 7 into any of these original denominators, would you get a 0? A 7 would, wouldn't it? This middle term, isn't 7 minus 7, like if that x were 7, what is 7 minus 7? That's a 0. So if 7 were a solution, I get 1 divided by 0. That can't happen. You're not allowed to divide by 0. So this is actually not a solution. That's extraneous. 1 is actually our only answer. Anybody else get just 1?
I did.
Really?
Before you said it.
Really? Really?
Yeah, I'm just a step ahead of it.
Really?
Really? What can I say?
Remember when you forgot how to factor?
I don't recall.
That's awkward. Alrighty.